In question 48, temperature and dew point in open room are given. If room temperature drops to 15 degrees Celsius, what will be the new dew point? Solution 48. So at temperature 20 degrees Celsius, dew point is 10 dew point is at 10 degrees Celsius. So this means place is saturated at 10 degrees Celsius. So if the temperature is dropped below dew point, it will remain unaffected, because at 10 degree Celsius a place is saturated. So if it is dropped below that, dew point will remain 10 degrees Celsius only. 49. Pure water vapor is trapped in a vessel of volume 10 centimeter cube. Find the volume of the vapor at which it will start condensing. So we will use this formula. The point where the vapor starts condensing, at that point vapor pressure equal to standard vapor pressure, P1 V1 equal to P2 V2. So RH SVP into 10 equal to SVP into V2. So V2 comes 10 RH, that is 10 into 0.4. So 4 centimeter cube will be the volume. In question 50, barometer is given to us. Find the relative humidity in space above the mercury column if saturation vapor pressure is given. Solution 50. So relative humidity, vapor pressure over Cp, 0.6 over 1, 0.6, that is, this means in percentage it will be 60%. So using the figure 24.6 in the book, we need to find the boiling point of methyl alcohol at 1 atm and at 0.5 atm. Solution 51. So the temperature will be approximately 65 degrees Celsius in the first case and 45 degrees Celsius in the second case when you look closely at the diagram. In question 52, human body has average temperature of 98 degree Fahrenheit. We need to find the minimum atmospheric pressure which is necessary to prevent the blood from boiling. Solution 52. So 98 degree Fahrenheit means 37 degrees Celsius approximately. So at 37 degrees Celsius, the graph of SVP is just less than 50 mm. So minimum pressure to prevent boiling is 50 mm of Hg. In 53, we need to calculate relative humidity in the room. Solution 53. So RH will be SVP at dew point and SVP at room temperature. 8.9 over 17.5, 0.508. That means 51% approximately. In question 54, we need to find mass of the water condensed. Solution 54. So at 50 meter cube, It contains 30 into 50, that is 1500 gram. And at 20 degrees Celsius it contains 16 into 50, 800 gram. So water condenses how much? 3 centimeter cube is this. 1500 minus 800, that is 700 gram, and this is at 30 degrees Celsius. In question 55, we have a barometer. Water droplets are slowly introduced in the barometer. The height of mercury column first decrease and then increase, become constant. So find the height at which mercury column when it reached the minimum value. Solution 55. So height of mercury column will be 76 minus 0.80 centimeter. Why? Because pressure is minimum when vapor present inside is at saturation vapor pressure, SVP. So this means 75.2 centimeter of Hg. In 56, we need to calculate number of moles of oxygen collected in the jar. Solution 56. So pressure exerted by O2, atmospheric pressure minus vapor pressure, 99.4 kilopascal minus 3.4 kilopascal, 96 kilopascal. Number of moles are N, which will be 8.3 to 300. Pressure is 96 into 10 to the power 3 into volume. So we get 1.93 into 10 to the power minus 3 approximately. In question 57, we need to find the length of the barometer tube above the mercury level in the reservoir. Solution 57. So let barometer length will be x. Height of air above mercury column, x minus 74 minus 1, x minus 73. Pressure of air, 76 minus 74 minus 1, that is 1 centimeter. And for second case, height of, this is for first case, height of air, x minus 72.1 minus 1 minus 1, x minus 71.1. And pressure 74 minus 72.1 minus 1, 0.99. So ultimately x minus 73 into 1 equal to x minus 71.1 into 0.99. So we will get x to be equal to 90.1. So height of air is 90.1 and height of barometer tube above mercury column will be 90.1 plus 1, 91.1. In question 58, we need to find the relative humidity in the room. Solution 58. Relative humidity is 40%. SVP 4.6 mm. of Hg, 0.4 Vp over 4.6. Vp will come out to be 1.84. P1V over T1 equal to P2V over T2. 1.84 over 273 equal P2 over 293. P2 will come out to be 1.84 over 273 into 293. So ultimately relative humidity at 20 degrees Celsius will be equal to Vp over SVP, 1.84 into 293 over 273 into 10, which will be around 0.109, that is 10.9%. In 59, calculate the amount of vapor that should be added. Solution 59. So we know this formula, 0.5 equal to Vp over 3600. Vp is 1800. P equal to M RT by V, 8.3, 300. So this will be added by this equal to 3600. So M will come out to be around 13 gram. In question 60, calculate the mass of water vapor present in the room. Solution 60. So PV equal to M by M RT. So equal to M by M 300. So M equal to 238.55 grams. So this is the mass of water present in the room. In question 61, find the relative humidity when the floor dries. Solution 61. So RH equal to Vp over SVP, 0.20 equal to Vp over 3.3 into 10 to the power 3. So Weber pressure equal to 660. PV equals nRT, P equal to nRT by V, M by M RT by V. 500 over 18, 8.3 into 300 over 50. So pressure will be 1383.3. So net pressure 1383.3 plus 660, 2043.3. Relative humidity 0.619, approximately 62%. In 62, we need to find how much water will evaporate. If temperature increased by 5 degrees Celsius, how much more water will evaporate? Solution 62. So for A part, relative humidity is Vp and SVP at 15 degrees Celsius, 0.4 Vp over 1.6 into 10 to the power 3. So Vp will be 0.4 into 10 1.6 into 10 to the power 3. So net pressure change 1.6 into 10 to the power 3 minus 0.4 into 1.6 into 10 to the power 3. 1.6 minus 0.4 into 1.6 10 to the power 3. 0.96 into 10 to the power 3. 0.96 into 10 to the power 3 into 50 m by 18, 8.3 into 288. M will be 361.45 grams. B part at 20 degrees Celsius, SVP 2.4 kilopascal. At 15 degrees Celsius, SVP 1.6 kilopascal. So net pressure change m dash 0.8 into 10 to the 2.4 minus 1.6 into 10 to the power 3. 0.8 into 10 to the power 3 pascals is the net change in the pressure. And mass of water evaporated m dash 0.8 10 to the power 3 and into 50. M dash will be 0.8 into 50 into 18 to 10 to the power 3. 8.3 into 293. M dash will come out to be 296 grams approx. And here it should be written like this actually: 0.8 into 10 to the power 3 into 50 equal to m dash over 18 into 8.3 into 293.